In this video, we'll look at two different implementations of creating threads, and we'll also look at how we can name our threads, how we can identify the current thread, and also how we can use the sleep method. We'll start by creating two classes. One class would extend thread, the other class would implement runnable. And let's say we are simulating the time that it takes to download a file. So if we start writing code for our classes, the first one we'll look at is where our class extends thread. So here, thread is the superclass or the parent class. So if we are to create a constructor for our download extends thread class, we can create our constructor like this, where we are taking the name of our thread and we're passing it on to the constructor of our parent class. And we might not need anything more here. The next thing that we need to do is define our run method. Now remember that the thread class has a run method, and so we'll have to override that run method. In the run method, we will define our task, and our task is to simulate the time it takes to download a file. So let's override the run method. Here, we will have our run method code. Let's say we start out by printing a statement, and that statement says that we are starting a time-intensive thread task, and this thread will carry out that time-intensive task. This part I'm using for coloring so that we can differentiate between the different threads when we get the output in our output console. And this part would make our printed statement print in blue. And so we want all of our printed statements to be blue for download extends thread. To show you how this is working, let's create a thread using our download extends thread class. So let's go to the main method, and here we'll create a new thread T1 using our download extends thread class that we just wrote. Now we need to start this thread in order for it to start execution. But let's print some informative statements before the thread starts. So we'll say that we're starting the download extends thread, and also we want the output to be in blue. So we start our thread T1 that we've already created here, and then we can print out another statement that says that this thread has been started. And just to show you the color differentiation, let's just print out something without using this color marker. Great. So now let's run the program and see how the output looks. What happened here is that we created our new thread T1 and then we printed out something in blue. So this statement has been printed here, and it says that we are starting our download extends thread. After that, our program starts our thread and then prints out that it has been started, and that is also an output that we get in our console. And you can see that both of them are in blue. Now, the thread has already started executing in the background, and so now our program prints this statement without any color markers, and that is why that is printed out here in black, which is the default color. Now, since the thread has started, it is doing some task. And if we go to our download extends thread class, the task that it would execute is within the run method. And in the run method, it is printing out something, again, in blue, and we see that output here. Where did this T1 come from? This is basically coming from this function here. So here we're using the getName method of the current thread. Current thread is a method of the thread class, which allows us to identify the current thread that is running. So once we identify the current thread that is running using the function up till here, after that we can use the getName method to get the name of the current thread that is running. And the name of the current thread is T1. Where did we assign this T1? If we go to the main method, we'll see that we actually initialized our thread using the name T1. And if we look at the function that we're using, the current thread's getName method gives us the name as an output. So I hope now you've understood how we can print outputs in different colors, and also how we can identify the current thread that is running. We know how to name a thread, and we also know how to get that name as an output. Please keep in mind that we named our thread in the main method T1 because it is using the constructor that we have defined in our download extends thread class. And that constructor actually passes the name that we input to the constructor of the parent. Here we have a parent. because we are extending the thread class. In the download implements runnable class, we will not have a parent class because we will not be extending thread. And there, the way we name our thread would be a bit different. And we'll see how that is the case. So just keep that in mind for now. Okay, so now let's move forward with defining our run method for download extends thread class. At first, we printed out that we are about to start a time-intensive task, a task that will take quite a good amount of time. As you know, downloading files sometimes takes quite a good amount of time, and it's usually not instantaneous. What we will do now is use the sleep method of the thread class, and we will make our thread sleep for around 1.5 seconds or 1500 milliseconds before it starts the download process. This is just so that we have a way to easily identify when the download has started, and a little bit of time will help us easily identify that in the output. We'll see how that works when we are running the code. But for now, what we need to understand is this is how we use the sleep method from the thread class. Now, you see that this is actually giving us an error because the sleep method throws an exception. That exception is a checked exception, which means that we need to handle it or else our program will not compile. The kind of exception that the sleep method throws is the interrupted exception. So we need to handle this exception. We will not go into the details of what interrupted exception is, but if you want to know more details about it, please take a look at the Java documentation. Okay, so now how do we handle this exception? What we do is that we need to put this statement in a try-catch block. And in the catch block, we catch the interrupted exception. When we catch the interrupted exception, we can print something out or we can just print the stack trace. It doesn't really matter what we're doing here. What's more important is to understand that we have not started downloading anything yet. We have not used a method yet that would simulate the time it takes to download a file. Great, so once we've printed this statement, we want our thread to sleep for a little bit, and then we start the downloading process. And let's say that we have some method that downloads files. What we will use is a method named download, which we will have to create, and that will simulate the time it takes for a file to download. So let's say our file takes around 6 seconds to download. So what we would want to do is simulate the thread working for 6 seconds. And to do that again, we'll use the sleep method. So let's define a method named download. Okay, so now we have a private method named download. And here, what we'll do is that we'll simulate the time it takes to download a file. And we'll just ask this thread to sleep for around 6 seconds by using the sleep method. At first, we'll print out that we are downloading a file, and this is just for information purposes, and we'll print it out in blue. We will then ask our thread to sleep for 6 seconds. Why are we doing this? Because we're just trying to simulate that a file is downloading in the background and it's taking 6 seconds to do so. As we've seen before, the sleep method throws an exception, which is a checked exception. So we need to handle it. Usually, whenever we create a method that throws these exceptions, we do not handle the exception in the method. We usually just specify that this method throws an exception. Whoever calls this method will then have to handle this exception. This concludes our download method. Let's recap what would happen if we create a thread using our download extends thread class, and then we start that thread. That thread will start to run whatever is in the run method. In the run method, it'll first print out a statement. It'll then sleep for 1.5 seconds, and then it'll start to download the file, which will take an additional 6 seconds, as we have defined in our download method. But here, download is giving us an error. Why? Because the download method uses the sleep method of the thread class, and we have defined it so that it throws an interrupted exception. Now, this statement also needs to be in a try-catch block, where the catch block is catching the interrupted exception. So why don't we put this in the try block that we already have in our run method? If any one of these statements throws an interrupted exception, we have one catch block that handles it. So if we create a thread using this class and start that thread, it'll come to the run method, it'll print this statement out, it'll it'll sleep for 1.5 seconds, it'll start executing the download method, and then we want to print out a statement that says that the task has been completed. So we can say that the time-intensive thread task has ended. Again, we print it in blue. So in the main method, we already have our thread created, and we have the statement to start our thread. We can delete this because we don't need this anymore. I'll quickly mention that this part resets the color for the output console. So whenever we're printing a statement and we want it to be a certain color, we put that color's code in the beginning, but in the end, we always have to reset the color to the default. And this basically is the color that this statement was printed on when we ran the code before. Before we run our program, let's make sure that all of the printed statements that come from the main method are a different color. We don't want them to be blue. Let's say we want them to be red. So we'll just change this code, and you can look up these codes on the internet. They're really not that important. This is only for the purposes of explaining threads clearly. Now, whenever we have any output from the main method, we'll see them in red, and whenever we have any output from our download extends thread class, we'll see them in blue. So let's go to the main method and actually run the program. So our program has started executing. It says that it's downloading. It'll wait for 6 seconds, and then we'll have a message that says that our time-intensive task has ended. So things happened really fast here. Let's slow it down and look at what actually happened here. At first, we created a thread and named it T1. We created that thread using our download extends thread class. In the main method, then we printed out the statement that says that we're starting our download extends thread, and that was printed here. After that, we start our thread. And at this point, there are two threads that are working simultaneously. One thread is the main thread, and the other thread is thread T1, which utilizes the download extends thread class. The main thread keeps on working by itself, while thread T1 works in the background and is starting to execute the run method. Since the very next statement in the main method is the print statement that tells us that we have started our thread, that is what gets printed next. In the background, our thread T1 has already started working, and what it's trying to do is it's trying to execute its run method. In the run method, at first it prints out that a time-intensive thread task has started, and that is what we see here. As you can see, it also prints out T1, which is the name that we gave to our thread. It waits for 1.5 seconds, and then it executes the download method. When it goes to the download method, it first prints out downloading, and that is what we see here, and then it waits for 6 seconds. So the thread is here for 6 seconds. Once the download method finishes, after 6 seconds, it comes back here and starts to execute whatever is after this statement. Since it did not catch any exceptions, it goes to this statement and prints out that our time-intensive thread task has ended. We don't have anything else in our main method, so the main thread has finished execution, and our thread T1 has also finished execution at this point. Now, if we rerun the program, I hope you'll be able to follow exactly what is happening. At first, these three things would be printed, but then there will be a slight delay of 1.5 seconds before we see this being printed, because we are delaying our program by 1.5 seconds here by using the sleep method. After that 1.5 seconds, you'll see downloading being printed here. It'll then wait 6 seconds because we are delaying our thread by 6 seconds by using the sleep method, after which you'll see this statement getting printed. So let's run the program, and hopefully you'll be able to follow what's happening. Our main thread has started, 1.5 second delay, and then downloading appears, 6 seconds delay, and then we have the statement that is printed at the end of our run method. Great. So now you know how to create a thread that works in the background and does whatever task we have assigned it in the run method. And we created that thread by extending the thread class. Let's look at the other implementation of creating a thread, where we use a class that implements the runnable interface. So we go to the other class that we created, and that is download implements runnable class. This is just the name that I have given to this class right now, but you can name it anything that is appropriate for the program that you're creating. We will make this class implement the runnable interface. And you know that the runnable interface has an abstract method named run. Since we have not defined the run method in our class yet, this is giving us an error, which says that we must implement the abstract run method. So let's override the run method, and here is where we will implement the code for our download task. Because we have overridden the run method, you see that the error that we were getting before is gone. So we will essentially do the same thing that we did before, and we will just take this code and paste it here. We're doing the same thing. We are printing something at first. We are asking our thread to get delayed by 1.5 seconds, and then we are calling our download method. At the end of the download method's execution, we print out that our time-intensive thread task has ended. In the download method, we print out that we are downloading something, and we simulate it by making our thread sleep for 6 seconds. This simulates that whatever file we were downloading might have taken 6 seconds to download. The key difference here is that we have implemented the runnable interface, and we have not extended the thread class like we did before. The only change here is the color. Before, in the download extends thread class, we had our statements being printed in blue, but for our download implements runnable class, we want it to be printed in green, so the color code has been changed. Apart from that, everything else is the same, exactly like we had it in the download extends thread class. So every output that we get from the download implements runnable class will be in green. Every output that we get from the download extends thread class will be in blue. And what we want to do is make sure that when we are getting an output from the main class, we get it in red. Let's go to the main method and create a thread using this download implements runnable class. So now let's create an instance of the download implements runnable class, and we call this instance dir. Remember that this statement does not create a thread because download implements runnable class did not extend thread, so we cannot treat download implements runnable class as a thread. Also, we have not defined a constructor for this class, so when we create a new instance of this class, the default constructor is used, as we can see in the main method. The important thing to remember here is that we have not created a thread yet. Here, since download extends thread class was already extending thread, it was a child of the thread class, this statement created a thread, and we named the thread T1. Since we have not created a thread here yet, in order to use this instance that we've created, we need to create a thread first. We'll call this thread T2, and we will use one of the thread constructors. Now, the thread class has many different constructors. One of the constructor is where you have to provide a runnable object first, and then you can name that thread. Our runnable object is dir. That runnable object is called the runnable target, and we have provided that by using dir. You can see that these are all the different constructors that we can use for creating a thread using the thread class. We will be using this constructor here, where we first provide a runnable target, and our runnable target is the runnable object dir, which is an instance of the download implements runnable class. We can now name our thread, and we will name it T2, and this statement creates a thread. Now we have a thread T2 whose name attribute has a string value T2, and it is going to be executing whatever is in the run method of our runnable target. We then print out that we are about to start our thread. We use the start method to start our thread, and then we print out that we have started our thread. We want the color of these statements to be red because these will be parts of the main thread, and now we're ready to test our code. We looked at how the program runs step by step when we discussed download extends thread class. The same thing will happen here as well. The only difference is that these are two different ways of implementing a thread. Let's run our program and see what happens. Our main method has started, the different threads have started as well. Both of them are waiting for 6 seconds, and then both of them finish and our program ends. What I would advise is to go through this code, try to understand everything that happened here, and then play with these numbers to see how it affects the timing in which our output statements appear. And hopefully that'll clarify the concepts discussed in this video a bit more. What we looked at in this video is two different ways of implementing a thread. We looked at how we can do that by extending the thread class, and we also saw how we can do that by implementing the runnable interface. We then created two threads that utilized these two different implementation methods, and we simulated downloading a file by delaying our thread by a few seconds. So now I hope you understand how to create threads by using these two implementation methods, and that you also know how the sleep method works, how we name our threads for these two different scenarios, and how we can get the name of the thread using the getName method. We've also looked at how we identify the current thread. In the next video, we'll look at call stacks and the difference between start method and run method.